Hi YouTube, this is Mike, also known as the Wizard of Odds, and the purpose of this video will be to show you how to analyze a slot machine. In this case, Jackpot Party by WMS, the traditional version. And what you're looking at right now is a portion of 18 minutes of play that I recorded in order to piece together the reel stripping. And this was incredibly time-consuming and tedious to record every single pattern of 3 symbols on all 5 reels. So let me pause for a minute to show you what I'm talking about. So on this game right here, you can see that on reel 1 I got a wild, a watermelon, and then an orange starting from the top. So at some other point in this play, I would have noticed a watermelon, an orange, and something else. So in 18 minutes of play, I recorded hundreds and hundreds of spins so that I saw every single way that the reels can stop at least once, and in fact many, many times. And with that, let me go over to Excel to start getting our hands dirty with the math. Hey YouTube, I am now in Excel, and to save some time I have already put into a spreadsheet the reel stripping, and this is all based upon that video footage that I took that I just talked about. So let's look at reel 1 for example. You can see that there are 26 stops numbered 0 to 25. Programmers like to start counting with 0, and the way basically slot machines work, and this goes back all the way to the very first slot machines in the late 1800s, is there is a circular reel, and it's on a circle, and there are different symbols on this reel, and the game will randomly pick a place to stop. And if the symbols that stop on the pay line match certain combinations on the pay table, then you win. And you can see that the number of positions on these reel strips is either 26 or 29. So with a video slot machine, they can be as long as you want because they are just virtual as opposed to physical like they used to be. And one challenge with this game is some patterns of 3 consecutive symbols occur more than once. It was the only way that I could get the reel strips to make basically a complete circle. And yeah, so basically how slot machines work. The way they don't work, contrary to common myth, is the evil, mysterious random number generator decides how much you win and then just shows you anything that matches it. No, it is the reel stripping that determines ultimately what you win. It's all very natural and according to how slot machines have basically worked from the beginning back in the late 1800s. So I also taken the liberty to put in this spreadsheet the pay table, and at this point I'm ready to start doing some math. So let's start by counting how often each symbol occurs on each reel. And for that I use the countifs function. So there you first put in the range of whatever you're counting and then whatever you're looking for. So I'm going to go over to the reel strip page to reel 1, which is in column B, and count, in this case, how often every time we see the Jackpot 7 symbol. And let's copy and paste that formula down through all 5 reels and all 5 symbols. And this shows us how often we see each symbol, which is very important to the math. And let's count it all up to make sure that we didn't forget any symbols. And so it's either 26 or 29, and that matches what we see here. And remember, we start counting at 0 because at least I am a programmer, and programmers like to start counting with the number 0. Moving right along, let's count up how often any given win can happen. In other words, the number of combinations for any given win. So let's start with the win for the Jackpot 7. And let's copy and paste the number of ways that can happen from 5 in a row to, in this case, 3 in a row. So the number of combinations to get the Jackpot 7 symbol on all 5 reels is simply the product of the number of times that it occurs on each reel. So it's going to be 1 times 2 times 1 times 2 times 1, which equals 4. So there are 4 ways you can get 5 Jackpot 7 symbols. So next let's do 4 in a row. So that is going to be the product of the number of times that it occurs on reels 1, 2, 3, and 4 times the number of ways it does not occur on reel 5, which is going to be 26 minus 1, or 25. So there are 100 ways you can get 4 Jackpot 7 symbols. And for 3 in a row, that's going to be the number of times or ways it occurs on reels 1, 2, and 3 times the number of ways it does not occur on reel 4, which is going to be 29 minus 2, and then the number of total stops on reel 5, because it doesn't make any difference what reel 5 is in this case, because the player got blocked on reel 4. So there are 1,404 ways the player can get 3 Jackpot 7 symbols. And in case I didn't say before, all wins in this game are left aligned only. So next let's look at the green 7s and blue 7s. So let's copy and paste down those wins. And the math there is going to be much the same. I'm going to put in a $ here so that when I copy and paste this formula, it's not going to change that row 25 for the total number of symbols. And then let me just make sure that these are consecutive. Jackpot green, blue. Yep, jackpot green, blue. So I can simply copy and paste these 3 formulas down to get the formulas for the green and the blue 7s. And then there's another line item on the pay table for mixed 7s. So to do that, let's create a little more space here. I'm going to create 3 extra rows. And in one of them, I'll put in this title here for symbol groups. So one of them will be any 7. And for that, I'm going to add up the number of occurrences of the Jackpot green and blue 7s. I'm going to copy and paste that for all 5 reels. So the number of ways to get any mixture of 7 symbols, doesn't matter what color, is the product of all 5 of these numbers. For 4 in a row, it's the product of the first 4 times the number of ways the player can get any symbol, which is 26, and then subtracting out 5. The 5 being for the number of 7s on reel 5. And finally for reel 3, we take the product of the first 3 reels, the number of 7s on each one, then the number of ways the player can get anything but a 7 on reel 4, and then the number of symbols on reel 5. Now, one thing that I didn't do yet is there's a lot of overcounting in these numbers. So next let's address that and subtract out the wins that could occur more than one way. So now we have to address the double counting problem. This has to be done very carefully. It's easy to make a mistake here. So first let's consider a situation where, let's say the player gets four Jackpot 7 symbols on reels 1 to 4, and then either a green 7 or a blue 7. So he could win either for 100 for 4 Jackpot 7 symbols, or the same amount, 100, for 5 mixed 7s. So since the win is exactly the same, we could count it either way we want. So I'm going to count it as 5 mixed 7s. So I need to subtract out of these 100 combinations the number of ways the player can get a Jackpot 7 symbol on reels 1 to 4 times the number of ways he can get a green or a blue 7 on reel 5. So that reduces that number of combinations from 100 to 84. So there's a similar double counting problem with getting 3 Jackpot 7 symbols. Notice that pays 40, and also 4 mixed 7s pays 40. So if the player got 3 Jackpot 7 symbols and then a green 7 or a blue 7, it would count both ways. So again, since they're exactly the same, I can choose which way to count it, and I'm going to count it as 4 mixed 7s. So I'm going to subtract out the number of ways the player can get a Jackpot 7 symbol on reels 1 to 3 times the number of ways you can get a green 7 or a blue 7 on reel 4, and then times the number of ways you can get anything on reel 5. So that brings down that number of combinations to 1,196. So next, let's deal with the double counting with 4 green 7s. If the player got a green 7 on reels 1 to 4 and then either a blue 7 or a Jackpot 7 on reel 5, he would get paid more for 5 mixed 7s than 4 green 7s. So let's subtract out those combinations. So that's going to be a green 7 on reels 1 to 4 times either a Jackpot 7 symbol or a blue 7. So that lowers that number of combinations to 504. And now let's think about 3 jackpots, 3 green 7 symbols. So if the player got 3 green 7s, which pays 25, and then a Jackpot 7 or a blue 7 on reel 4, he would get paid more for the combination of 7s at 40 than he would for 25. So we absolutely need to take out those from the combinations of 3 green 7s. So we're going to subtract out the product of 3 times 2 times 2 for the green 7s on reels 1 to 3 times the number of ways he can get a Jackpot 7 or a blue 7 on reel 4 times the number of ways he can get anything on reel 5. So that takes that one down to 7,176. Next, let's do the same kind of thing, but for the blue 7s. So for the 4 blue 7s, I'm going to subtract out the number of ways the player can get 4 blue 7s times the number of ways the player can get a Jackpot 7 or a green 7. So just to make sure I'm doing this right, the player would get paid 50 for 4 blue 7s or 100 for 5 mixed 7s. So we absolutely should subtract out those combinations where he gets paid both ways. So that brings down 4 blue 7s down to 336. And for 3 blue 7s, if the player got a blue 7, blue 7, blue 7, and then another type of 7 on reel 4, he would get paid more for the 4 mixed 7s. So we need to subtract out those combinations that we're previously double counting. So that's going to be 2 times 2 times 2 times the number of ways the player can get a jackpot 7 symbol or a green 7 on reel 4, which is 2 plus 2, times 26, which is the number of ways you can get anything on reel 5. So that brings that one, 3 blue 7s, down to 4,784. Next, let's consider the number of wins for 5 mixed 7s. So that is double counting the number of ways the player might get 5 of the same type of mixed 7. So let's subtract out from that number of combinations the number of ways the player can get 5 of the same type of 7. And that brings that one down to 5,316. And here, let's subtract out the number of ways the player can get 4 of the same 7 symbol. And here, subtract the number of ways the player can get 3 of the same 7 symbol. So there we go. There are all our combinations for the ways the player might get wins based on 7s. Next, let's calculate the wins for the bell, and that's going to be pretty easy. So the number of ways the player can get 5 bells is the product of 2 times 3 times 4 times 4 times 3, the number of bell symbols on each reel. So the number of ways the player can get 4 bells is the product of the number of ways he can get them on reels 1 to 4 times the number of ways he can get anything except a bell on reel 5. So that number of combinations is 2,208. And the number of ways he can get 3 bells is the number of ways he can get them on reels 1, 2, and 3, times the number of ways he can get anything but a bell on reel 4, which is 29 minus 7, times the number of ways he can get anything on reel 5. So 15,600 there, combinations for 3 bells. So next, it gets a little bit more complicated with the fruit symbols. So let's add in some more groups. So it's complicated because we have this wild fruit symbol, which can count as any fruit. So I'm going to create a category for a watermelon or the wild fruit. And let me make this column a little longer. And I'm going to copy and paste that down for the other types of fruit. So the types of fruits, there's 4 different types. So let me copy and paste one more row. And so the number of ways the player can get a watermelon or a wild fruit in reel 1 is going to be 3 plus 2. And I'm going to put a dollar symbol in front of this 19. So when I copy and paste this formula down, it's going to stick with the number of combinations of wild fruit. So I can copy and paste this down to get the groups for any of the 4 types of fruit or a wild for all 5 reels. So next, let's consider, so the watermelon is the highest paying. No, let's start with the wild fruit. And again, we will deal with the double counting later. But the number of ways the player can get 5 wild fruit are just the number of ways it appears on all 5 reels. So that's going to be the product of 2 times 1 times 1 times 1 times 2. So the number of ways he can get 4 wild fruit is the number of ways he can get one on reels 1 to 4 times the number of ways he can get anything but a wild fruit on reel 5. And the number of ways the player can get 3 wild fruit is the number of ways he can get them on reels 1, 2, and 3, times the number of ways he can get anything but a wild fruit on reel 4, times the number of ways he can get anything on reel 5. And this game pays for 2 wild fruit, so that's going to be 2 times 1 for reels 1 and 2, times the number of ways you can get anything else on reel 3, times the number of ways you can get anything on reels 4 and 5. And finally, and I don't see this very often anymore, but the player can get paid for just 1 wild fruit. It's going to be 2 times the number of ways you can get anything else on reel 2, 29 minus 1, times the number of ways you can get anything on reels 3, 4, and 5. And again, we will deal with the double counting later. Next, let's find the combinations for the watermelon, plum, orange, and cherry. So I'm going to copy and paste those symbols down, and let's start with the number of combinations for 5 watermelon. And remember, there is a wild fruit symbol which can count for any fruit. So that's simply going to be, we already did these groupings earlier of any given type of fruit or a wild. So that number of combinations is just going to be the product of these numbers right here. For 4 watermelon, we take the product of the first 4 of them for reels 1 to 4 times the number of total symbols or positions on reel 5 minus the number of watermelons or wilds. And I'm going to put $1 in front of that 25 because I'm going to be copying and pasting that in a minute. And for 3 in a row, we do the first 3 reels times the number of ways to not get a watermelon or wild on reel 4 times the number of total stops on reel 5. And again, we're going to put a $sign in front of the 25s. And now we're going to copy and paste those formulas down to get the combinations for the other 3 types of fruit. Okay, next let's deal with the dreaded double counting problem. So first let's look at the wild fruit. Right now we show 48 ways to get 4 of them on reels 1 to 4. And let's go up to the pay table here. So 4 wilds pay 50, but 5 watermelon or plum pay 150, and 5 orange or cherry pay exactly the same thing at 50. So we need to decide which way to count something like wild, 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 orange. That's going to pay 50 either way, whether you count it as 4 wilds or 5 oranges. And I'm going to just arbitrarily decide to count it as 5 oranges. It's just a habit of mine that I like to count it the way that there are more symbols. So let's go down here to the number of combinations for 4 wilds, and I'm going to subtract out I'm going to subtract out the number of ways to get anything minus the number of ways to get a wild or any kind of a fruit. So that brings that number of combinations down to 20. And next let's do 3 wild fruit. So let's look at the pay table. 3 wilds pay 10, and 4 of any specific fruit pay at least 10. So let's adjust that formula to for real 4. Right now we're only taking out the wilds, but instead let's take out the number of wilds or any kind of fruit. So that brings that number of combinations down to 520. So next let's look at 2 wilds. So 2 wild fruit pay 5, and 3 of any specific fruit pay at least 5. So let's adjust our combinations for real 3. Previously we only subtracted out the wilds, but now let's subtract out the wild or any specific kind of fruit. So that brings that down to 16,588. And now let's look at 1 wild. So 1 wild pays 2, and 2 of it, any fruit. Okay. 3 of any fruit pay at least 5. So we're going to need to subtract out things like things like wild and then cherry, or wild orange. Next, let's deal with this combination of 1 wild fruit. So currently the way we have it is the number of combinations of a wild on reel 1 and anything but a wild on reel 2, and then anything at all on reels 3, 4, and 5. So we need to subtract out combinations like wild, watermelon, anything, wild, plum, anything, and so on. So let's do that. So I'm going to subtract out the wilds, the number of wilds on reel 1 times, for reel 2, I'm going to subtract out the number of ways you can get a watermelon on reel 2 times the number of ways you can get a watermelon or wild on reel 3, plus I'm going to subtract out the number of ways you can get a plum on reel 2 times the number of ways you can get a plum or a wild on reel 3, plus the same thing for an orange, and then the same thing for a cherry. And then the number of all stops on reel 4 times the number of stops on reel 5. So that brings us down to 968,136 ways to get 1 wild on reel 1. Next, let's deal with the overcounting problem with 5 watermelon. So all we need to do there is subtract out the number of combinations of 5 wilds, which is 4. So for 4 watermelon, let's subtract out the number of ways the player can get wilds on reels 1 to 4, and the probability of not getting a wild or a watermelon on reel 5. And for 3 watermelon, let's subtract out the number of ways to get wilds on reels 1 to 3 times the number of ways to get anything but a wild or a watermelon on reel 4 times the number of ways to get anything on reel 5. And next, let's put in some dollar signs, so when I copy and paste that down, the formulas will still work. So any place, let's see, yeah, 19 is an important column, an important row we don't want to mess with, as well as 25. So putting $1 before the 19s and the 25. And let's copy and paste those formulas down. Next, we're ready to figure out how much the game pays back to the player in terms of all these line pays. We've had the combinations, which was the hard part of this. In fact, let's title that just to make that look better. Let's insert a row. So here are our combinations. And now let's do winning probabilities. So let's copy and paste this table down and delete the numbers from it. So the probabilities are going to be let's add something. Let's calculate the total number of combinations. And that's going to be the product of the number of stops on all 5 reels. So there we go. There are almost 15 million possible outcomes in this game, the way the reels can stop. So to get the probability of any given event, we just multiply the winning combinations divided by the total combinations. And I'm going to put dollars in that total combinations cell because I'm about to copy and paste it. And let's put those numbers in the form of let's do 8 decimal places. So there are all our probabilities. And let's take a total of each column as well as each row. So cell G63 over here is telling us that any given pay line has a 10.63% chance of winning something as a line pay. And now, to get the contribution to the return, it's very simple. We just multiply the probability by what it pays. So here's the probability, and we go up to the pay table to see what it pays. And I believe that everything is still in the same order. The combinations are in the same order as the pay table itself. So we just need to copy and paste that formula. And this is telling us that the line pays return about 65.42% of the return. And let's do that to 6 decimal places. So there we go. This was much of the project right here. 65.42% for the line pays. Now we just have to, next let's analyze the bonus. Next, let's talk about the bonus. So first let's go over the rules of it. Okay, so in this spin here, you can see I got the party symbol on reels 1, 3, and 5. They only occur on those reels. And if you get the party symbol on all 3 of them, then you get to play the bonus. So let's move on. So in the bonus, there are 30 different gifts, and each one contains some amount of credits, and I think 6 of them also have what are called party poopers. And you can keep picking and opening gifts and accumulating all of them until you get to a party pooper. So let's go on. So my first pick was 45, and then 135, and then I got a party pooper. And notice that the party pooper still paid something. And notice how it kindly shows you all of the possible prizes. And this distribution is always the same. Relative to the amount that you bet. All these prizes have been multiplied by 9 because I bet 9 credits. And we can see there are 1, 2, 3, 4, 5, 6 party poopers. So let's go back to Excel and do some math. We are now ready to analyze the bonus. I took the liberty of counting how often each prize appears in the field of 30 gifts, and I put it here. For example, a win of 1 appears twice, a win of 2 appears 5 times, and so on. And there are 6 party poopers, and this is always the same. The distribution is always the same. So first, let's calculate the probability of triggering the bonus. So that is going to be, so let's go over to the line pays sheet. So it's going to be the number of times the party symbol appears on reel 1 times 3, because it can appear in any position on reel 1 because it's a scatter pay symbol, and then divide that by the total number of positions on the reel. I'm just going to hit enter to see what it looks like right now. So there's a 23.1% chance that it appears on reel 1. And then let's do the same kind of thing. In fact, exactly the same thing for reel 3. It appears twice on reel 3. Multiply by 3 for the 3 rows and divide by the number of positions on the reel. And then finally the same thing for reel 5. So this is showing us the probability of the bonus is about 1.23%. Okay, how about the average prize? And I'm not going to count the party poopers. In other words, if the player does not get a party pooper, what is the average prize? So for that, we can use the sum product function, which in mathematical terms is the same thing as the dot product. So I take the array of wins and then the array of how often they appear. So if I stopped right here, this would tell us that there the total number of prizes is 144. But we need to divide that by the total number of prizes, which is 30 minus 6, or 24. So that's telling us that the average prize is exactly 6. So how many prizes can the player expect to pick before a party pooper? I emphasize before and not including the party pooper. So there's a handy mathematical trick you can do, is you take the total number of prizes, which is 30 minus 6, or 24, and then you divide by the number of party poopers and add 1. So that is telling us the player can expect to pick 3.43 prizes before he gets a party pooper. So if we take the average prize of 6 and multiply it by the number of prizes, we get an average win of 20.57. However, the party pooper also comes with a win of 1. So the player always wins at least something. In the unfortunate case, he gets a party pooper on the very first pick. So we're going to add 1 to that for the 1 he gets for the party pooper. So that's telling us the average win is 21.57 credits. So the return from the bonus is going to be the probability of triggering the bonus times the average win. So this is telling us that 26.5% of all money that the player bets is going to come back to him in the form of bonus wins. So we're just about done here. I created a summary sheet to summarize just the 2 ways the player can win. From line pays, we calculated that the player can expect to get back 65.4% of his bet. And from the bonus, you can expect to get back 26.5%. In other words, the total return is 91.93%. So that is it, YouTube. I hope you liked this video, and I hope that either it taught you something about slot machine design or how to use Excel, or better yet, both. As long as you learned something, it's all good. So again, bottom line here of 91.92%. And let me say that that doesn't mean that every jackpot party is set to this return. The way most slot machines are made is they come with a number of different returns the slot manager may choose from, typically ranging from 85% to I would say 94%. And most casinos in Las Vegas tend to pick them between 85% and 92%. So this would be one of the more liberal versions. What changes between one and the other? It's just subtle changes in the reel stripping. The more generous returns will have more wilds and things like that. Usually the bonus is exactly the same from one to the other. So again, one thing I really hope you took away from this video is just the simplicity of the design. It's just reel stripping and random numbers. And in this case, the player did have free will over his outcome in the bonus. That is not always the case. So I can't think of anything else to say, but leave your comments in the video description, and if I get enough good feedback, I will make other videos where I deconstruct other slot machines. So thanks for watching, YouTube, and I'll see you in another video. Bye.